Today we're going to talk about confidence intervals. As we're going through these problems in this section, we are going to be using some of the same tools that we used when we were going through and talking about our central limit theorem in section 7.3. So in section 7.3, when we were using our central limit theorem, in most cases we were given our population parameter, our p, and then use that to find different probabilities for our p hat, right, for our sample proportion. In this case, in this section, what we're looking for and what we're going to try to answer questions about, what if we don't know p? What if we don't know our population proportion? So what we're going to use is we're going to use our p hats, we're going to use our sample proportions and try to estimate possible intervals where our proportion, our p, is going to live. So our confidence intervals, they provide us with a range of plausible values for a population parameter. They are often reported as our estimate, our statistic, plus or minus some amount. That some amount that we are adding or subtracting is called our margin of error. And the margin of error tells us how far from the population value our estimate can be. So what we see here is a general kind of formula or way we're going to set up our population, our confidence intervals for our population proportions. Right, so our confidence interval, we're going to take our p hat, our sample proportion, plus or minus our margin of error. Right, confidence intervals are going to tell us some different things. To be clear, kind of as we're going through these problems, they are not the same as our probabilities from the last section. So in the last section, we were looking for probabilities. In this section, what we're going to do is we're actually going to be making estimations. Right? They are based off of our confidence levels, which we're going to talk about as we're going through these next few problems. And they tell us how often the estimation is successful. Again, they measure the success rate of the method, not one particular interval. So kind of as we've talked about before, a lot of what we're looking at for these different problems is our method going to provide us with accurate results, and our confidence levels are going to tell us how good of results that we can expect based on our method. All right, so in these first two examples for today, we're just going to focus on our interpretations. So as we've seen in previous chapters, writing out a sentence interpretation for our answer is going to be kind of a key for a lot of these problems. So we're going to focus on that to begin with, and then we'll go through and kind of talk about how we can work through the entire process of finding a confidence interval as a whole. All right, so a mortgage is underwater if the amount owed is greater than the value of the property that is mortgaged. A 2013 Rasmussen poll of 715 homeowners in the United States found that 62% of them believed their homes were not underwater. The margin of error is plus or minus 4% with a 95% confidence level. Now we're going to start by stating our confidence interval, and then we're going to interpret this interval and also explain what the 95% means. Okay. So the first thing that we're going to do, just like we did in section 7.3, is we're going to list our variables. In this particular example, I didn't list our capital N. Our capital N is our population, so that it would be all homeowners in the United States. But we are going to start with our lowercase n, our sample size, right? And we get 715 homeowners in the United States. And so capital N is always our population, our lowercase n again is always our sample. Our p hat is the percentage from the sample. Right? So in this particular sample, 62% of the homeowners believed that their homes were not underwater. Just like we did in the previous chapter, any of our percentages we're going to write as decimals. So our 62% is going to be 0.62. Our margin of error is 4%. Again, we're going to convert that to a decimal and write that as 0.04. Right. Our confidence level, we're always going to be given a percentage for our confidence level. So in this case, we are given a confidence level of 95%. Right. And what we want to know, what we are looking for, is the confidence interval. And our confidence interval is always set up p hat plus or minus. Right, so we're going to start by stating our confidence interval. So we're going to take our p hat plus or minus m. Right, p hat is 62%, so 0.62, plus or minus our margin of error, which is 0.04. So we're going to take this and we are going to subtract 0.62 minus 0.04, and then we're going to take our 0.62 plus 0.04. Right? So if we subtract 4% from 62%, we get 58%, or if we do it as our decimals, 0.58. And then if we add our 0.62 plus 0.04, we get 0.66. So to find our confidence interval, it's a simple subtraction and addition to find our lower limit and our upper limit, as we're going to refer to them in problems when we're using StatCrunch. All right, so we're going to start by answering the question, what does that 95% mean? Right. So the confidence level of 95% tells us that if we conduct many surveys, (95% of them would result in confidence intervals that include the true proportion. So our confidence level tells us that if we were to repeat this over and over again, if we were to do a bunch of different surveys instead of just this one survey of 715 homeowners, 95% of those surveys would result in confidence intervals that include our true proportion. Our confidence levels, we're going to see a lot of times we're going to use 95% as our confidence level. And then we'll also see some other cases where we might use 90% or 99%. But it's generally going to be a high percentage because we want to be ending up with answers that are representative of our true proportion. Okay. All right, our interpretation. So every single one of the problems that we're going to work through in this section, we're going to look for an interpretation. All right, so it is as we're going through these problems, kind of the sentence that you're going to be writing more often is going to be this interpretation part. So how are we going to interpret this interval? All right, so we do want to make sure we know what the 95% means, but the interpretation that we're going to write in this last sentence, this is the type of answer that is going to be more representative of most of the homework problems and or other examples that we're going to be going through. All right, so our interpretation, we're always going to start by mentioning our confidence level. So we're going to say we are 95% confident. Right. So we're going to start by mentioning our confidence level that the population of all U.S. homeowners who believe their home is not underwater Right, so after we state our confidence level, we're going to mention the population that we are looking at. Right, so our population of all U.S. homeowners who believe their home is not underwater is between 58% and 66%. So then we're going to finish off our interpretation with the confidence interval that we obtained. And so again, our interpretations, we're going to be looking for our answer for all of these problems to be in a sentence. Right, so we're going to start, we are 95% confident, mention our confidence level, mention the population in question and what we're looking for. So our population of all U.S. homeowners who believe their home is not underwater, and then we finish it off by mentioning our confidence interval. right, is between 58% and 66%. All right, let's work through another example. Again, we're going to focus on our interpretation, and then we're also going to see another type of question that can be asked. So in addition to our interpretation, we may be asked some sort of additional question or be asked for some additional information after we finish the problem. So a random sample of likely voters showed that 49% plan to support Measure X. The margin of error is 3 percentage points with a 90% confidence level. All right. So we're not given specific information about our population or our sample here, but we are given a sample proportion. So our 49% is our p-hat. Again, we're going to write it as a decimal, so 0.49. And we are given a margin of error, 3 percentage points. Right, so 3% equals 0.03. Right, in this case, we are told that our confidence level is 90%. Right. And just like we were looking for in the last example, we are going to be looking for the confidence interval, which again is still p-hat plus or minus m. All right, so we're going to start by stating our confidence interval. Right. So p-hat plus or minus m is going to be 0.49 plus or minus our 0.03. So we're going to have 0.49 minus 0.03. We usually do the subtraction first, just because that way we have the lower number as the first part. And then 0.49 plus 0.03. Right? And we get a confidence interval of 0.46 to 0.52. Right? We are using interval notation. Our interval notation just shows the two limits, the left limit and the right limit, with a comma in between them, separated to show between the two values, and then we have parentheses on both sides. All right, so how would we interpret this interval? So just like we did in the previous example, we're going to start by mentioning our confidence level, then we're going to mention the proportion in question, and then we're going to give a range of values. So we are 90% confident that the proportion of voters who will support Measure X is between 46% and 52%. So our confidence level, our proportion that we're looking for, and then our range of percentage that we get for our confidence interval. Right. Then we're asked an additional question here. Right? Is there evidence that Measure X will fail? And if we're thinking about something either failing or passing, right, we want to think about that 50% cutoff. Right? In this case, we have values that are both above and below our 50%. If our entire interval was above 50%, well, then it would most likely pass. Right? Because we have, in this case, values that are less than 50%, right, that means that there is a possibility that Measure X could fail. Right? So in order to pass, our entire interval would have to be above 50%. Our entire interval is not above 50%. Our interval goes from 46% to 52%. So we are going to say yes, there is evidence that Measure X may fail. Right? We don't know for sure that it will, but there's evidence that it could possibly fail because there are values in our confidence interval that are below 50%. So measure X could possibly fail because we have values that are below 50%. Right? It could also pass because we have values that are above 50%, but we don't know for sure either way. Right. Suppose the survey was taken on streets of Miami and the measure was a Florida statewide measure. Explain how that would affect your conclusion. Right. So here we're kind of going back to where we started in chapter 7, and we want to think about our samples. Right? Is our sample random? Is our sample a good, unbiased representation of our population? Right? In this case, a sample from Miami does not represent the entire population of Florida. Therefore, the sample is biased. So as we're thinking about going through these different problems, we want to make sure that we have a randomly selected sample, right? Independent, random and independent, same type of things that we saw back in section 7.3, and we want to make sure it's a good representation of our population. Right? In the next video, we're going to go through not just our interpretations of our confidence intervals and what our confidence intervals are looking at, but how we can actually generate confidence intervals based on information that is given to us.